So as we just saw, adding the control device to our project, in this case it was an orifice, was resulting in an issue. You can see here the main problem is that the storage that is provided does not meet the storage that's required, and as a result the high water level exceeded the top of our control and started overflowing from the system. Now behind the scenes, InterHyd is doing the modified rational method calculation to determine how much storage is required based on the drainage area and the discharge from the controls. And if that can't be met, it's then indicating that there's an overflow. So what this tells us is we need to provide more storage. Now, storage can be provided in a variety of ways. InterHyd is already accounting for all of the storage in the physical structures. So manholes, pipes, catch basins, each of those has a volume associated with it. And InterHyd is going to calculate based on the high water level for each event, what is the corresponding volume. So one way to add more storage is you can make your pipes bigger. So in this case, we have a 675 pipe. 675 is the smallest pipe size that was determined for the storm sewer conveyance calculations. But we can set this to a higher number, let's say a 1050, in order to have more storage. So if I go back to our table, you'll see here the storage provided jumped up from about 70 to 120 cubic meters. As a designer, you obviously make decisions about which pipes you want to oversize or not. One of the other ways you can add storage would be to actually change the type of pipe. So this is where you could actually change the catalog that is being used. So by default, there's a circular storm sewer, but you can also enter in your own custom catalogs. In this case, I've got one called a box culvert, which has its own associated sizes. So again, a box culvert is going to provide more storage. And you can see here, we're now providing about 150 cubic meters, which does meet the requirement for the 2-year storm. And you can see that the high water level is now lower than the top of our manhole, and we are no longer overflowing. So for the 2-year, we now have a valid solution. Obviously, we do not yet have a solution for the remainder of our storms. So the final thing you can do is you can add in a storage component, and that is this bottom component here. And just like we did with the control device, it's going to show an icon which you can click to add into the plan view, and then the arrow you can click to add it to the node where it will be connecting into. When you click on this, you'll see here it says relative to, and you've got invert, top, fixed elevation, and absolute elevations. For now, we're going to just say invert. So think of this as storage that is going to start at the bottom of this node. And you can click on the edit storage table, and here you can actually enter in the stage storage relationship. So if we wanted to define, let's say, an underground tank, we can set a depth of 0, let's say up to 1.5 meters deep, and an area of 500 square meters. And so you'll see here this bottom 200.21, because that's relative to the invert, it's going to match the invert that we are connecting into. Just like we saw for the control device, you can set this as a relative value. So if you wanted this tank to only start, let's say 30 centimeters above the bottom, you could just say bottom plus 0.3 centimeters. It'll also tell you the top and the total depth and volume within that storage. So this would be for an underground tank. We'll just quickly look at our results again, because you'll see that there is no longer any red in our overflow column. And the reason for that is we are now providing enough storage up to the 100-year event that all of the flow is discharged without exceeding the overflow elevation that we have set. Now, if you wanted to do, let's say, parking lot storage, so I'll just come up here where we have a catch basin. Let's say you were defining some surface storage within this parking lot. You can also add in a storage component. We'll link it to this catch basin. And here, where it says relative, we are going to click on top. And you'll see that the bottom, so that's the bottom of the storage, is now at 203.39, which is equivalent to the top of this catch basin at 203.39. So you can think of this as saying the storage is only going to start at the top of the catch basin. And then if we go and edit our storage table, again, if we have a depth, let's say, of 0 meters at the top of the catch basin, and a 0 square meters area, and let's say it extends to a maximum depth of 0.3 meters over, let's say, 200 square meter area. It'll now provide you that total depth and volume. So if ever the high water level in the system exceeds this bottom elevation, it's going to start utilizing that storage.